Hi everybody. In this episode we're going to align the tuner section of this Yamaha CR820. Okay, a couple of things before we get started on this tuner alignment. And this is a little bit different than your just standard receiver from this era. It does have a couple of features that you normally only see in some of the higher end receivers, not a little 50-watt receiver like this. But there's also some things that I don't like about it, so we'll talk about it real quick. The first thing in this is a function called the OTS tuning system. And what that is if you go back and look at a couple of the videos I've done in the past, I did a couple videos on a Pioneer TX9800 and the SX1980 receiver. Both of those had a similar function where it has a touch sensitive sensor on the tuning knob. So when you put your hand on the tuning knob to rotate it, it unlocks the tuning lock, I guess you could call it, on this. On the TX9800 and the SX1980, it's actually like a quartz lock or a servo lock kind of circuit. And you rotate the tuning knob until you get approximately on the station, get it as close as you can, and then as soon as you let go of the knob, it senses that you've let go, and that locking system comes in, and it just brings the signal right on to, right on frequency. So that's kind of a neat little function on this. And that's done. It's kind of interesting the way they do it. If you look right here, they show where the tuning knob is. And you see this wire going off here, and it goes to this little, it's a symbol for a capacitor, and it has this little black dot. This is actually the capacitive touch sensing circuit right here. So when you touch the knob, it goes through this capacitor and through this resistor and then up into here, which activates that frequency lock circuit. And you can see it's all analog. So it's not, it's not your typical quartz lock, but instead just a little more basic version of it. And it works fairly well, actually. Pretty impressed with the way it worked. Another thing I like about this tuner is instead of having just, discrete transistor amplifiers for each of the IF amplifier stages, you can see there's 3 integrated circuits, IC 101, 102, and 103. And those amplify the IF stages. And those always work really well, so I like that. The multiplex circuit for taking the FM and stripping the multiplex signal off of it and getting your right and left stereo outputs, that's all done through an individual chip. And one of the things I do not like about this is the muting circuit the muting disable circuit, I should say, is on the same switch as the stereo mono switch for the FM. So basically, if the muting is turned off, it disables the stereo from working. So it cannot switch into stereo mode if the signal is muted. And the muting threshold is set relatively high on this thing. And that's a problem because unless you have a really strong signal, this thing will not unmute. And if it would unmute, you might get a little bit of static, but there's enough carrier there to actually get a usable stereo signal with a little bit of static. And in most receivers, you can adjust that threshold. It's called muting threshold. On this one, there's no adjustment for it. It's all done inside the chips, and there's no way you can change it. It's all done through this circuit and through this circuit here combined, and you can't adjust it. There's no pot, there's no anything. I'm sure you could mess around with some of the values of the resistors and things to change it, but that would be a lot of experimenting. It's very frustrating. and I don't like that about this. So as a result, you're going to listen to most of your FM stations, unless they're really strong, you're going to listen to them in mono, and you just have no option for that. The other thing is, I'm not a fan of muting. I like to hear the static, and I like to hear the stations as I'm tuning into them. So muting to me is kind of a moot point, or a mute point, I should say. So that's kind of a couple of comments I have. Last but not least, I did notice, if you go here, looking at this diagram, and I'll move this over to here right now. When you look at this diagram, you can see the stereo left distortion. Well, the instructions are, and you're going to see this later on, the instructions show you to adjust this, and this is the only pot that they show. Even in the schematic here, they show that pot right back here, the VR101. But there is also a VR102, and you can very clearly see it down here, VR102. There's 101, there's 102, but nowhere in the schematic do they show that potentiometer. It's actually not in the schematic. And what it actually is, I guess you could call it the distortion right, or distortion R, stereo R distortion. And these two pots affect one another. So when I go through the procedure, you'll see that I just do this one, but you really need to adjust both of these, and you go back and forth and you check the distortion of the right and the left channels, and you set these so that both channels have a minimized THD. So just keep that in mind. That is not in the instructions, it is not in the service manual, and it is not even in the schematics. So here are those 3 IF amplifiers. And by the way, if you want to inject an RF, like an IF signal of 10.7 megahertz with a carrier, you can actually go through a coupling capacitor, and if you touch pin 2, which is right here, and pin 2 and pin 2, you can check each individual IF stage by doing that. I don't do that, but you can. So that's about it. Let's get moving on the alignment, and we'll go over it and see how everything turns out. I have everything set up, and the very first thing they have you check is the pointer of the dial, and they're just making sure that at center of dial, which is going to be 98 megahertz on FM, is that the pointer is pointing at 98 megahertz. Now what they're saying is to connect to the FM antenna input, which we've done. You can see that over there where it's connected. And we're going to use, for this first part, we're going to use the 8657 signal generator, and I'll show you why here. What they're asking for is, by the way, this isn't super important, but they're just giving you this as a reference. They want 98 megahertz, and they want the amplitude to be 60 dBu, which means decibel with reference to a 1 microvolt. Now, we can do conversions to actual EMF microvolts or dBm or different things like that, but it's really easy if you have one of these types of signal generators, because, let's see if you can see this here, all you do is you type in amplitude 60 dB with respect to microvolt, and see it says dBUV. Boom, you're done. Now remember, this thing is terminated at 50 ohms, and most stereo receivers are terminated at 75 ohms. So when you start looking at watts, like power and so forth, that's not going to work. But from a voltage standpoint, that's what we have. I did a few videos on the differences and so forth. You might want to go back and look at. All right, so the next thing we want to do, and I'm already there, you want to tune the dial right to 98 megahertz. And we're right there. And while we're doing that, we're going to check our tuning meter and make sure we're centered. We're going to get as close to centering as possible. And we're pretty much right on. And if we look at the scope, we have a perfect sine wave. And all I'm doing is I'm connecting the oscilloscope to the recording output jacks on the back of the receiver. So we're just using record out. And we're just monitoring the signal right there. So this first step, we don't have to do anything. Now, if we did have to do something, we'd have to loosen up these clamps on the dial string, and they want you to move the dial until you're right on 98 megahertz. So there you go. Step 1 done. Okay, for step 2, we are going to check the 108 megahertz position on the dial scale. So we're just going to switch our signal generator up to 108 and move our dial to 108 and plus or minus 2 millimeters from the mark. So we'll go down here, go to 108, go up here, frequency 108 megahertz, and what do you know? We're right on. And if we look at the meter, that tells the truth about how centered we are. So we want to move it just a little bit over. We're pretty close. You can see we're within that 1 to 2 millimeters there. Let's go to the other side now. Now we're going to go to 88 megahertz. And we're going to look at that. And we're going to trim the tracking error. And then when proper adjustment cannot be made by step 3, they're going to have us adjust the carrier by the pointer and TCO alternately. So we're going to go 98 megahertz and then 108. We're going to adjust TCO, TC0. Or trimmer capacitor 0, we should say. Okay, TCO is right here. And we're going to adjust that. And that is going to be right above the tuning gang. So that's going to be this one right here. So that's what we're going to adjust. We're going to use a non-conductive tweaker. And all we're going to do is we're going to go directly onto 108 right here, like so. And you can see it, the dial's kind of jumpy. We're very, very close. You can see that. I don't know if we can zoom in a little better. And we'll just adjust that little adjustment there until we're right on. We're really splitting hairs here, aren't we? And there we go. That's very touchy, especially around the camera. How's that? Looking straight on. I'm probably going to have to move the camera out of the way to get the adjustment. Let me back this up. Maybe you could see the whole thing from here. I don't know. Can you see it all in there? Maybe not. Okay. So let's go here. Get on there. Hold my tongue in the right position here. There we go. And you can see we're right on now. Okay. Now they want us to go back to 98 and check that again. Frequency, 98 megahertz. And you can see it's just slightly off to that side now. And you can see that's the only adjustment they give you for that. Okay, we just barely have everything in here. So I adjust that one trimmer one more time. And right there is 108. And you can see where the meter is. And we go down to 98. And I'll go frequency 98 megahertz. And we're right on. So that's very, very close. Okay, for the next step, they want us to adjust the tracking of the AM section. And we're going to do the local oscillator for AM. And that's going to be adjusting T401. They want us to radiate a signal into a bar antenna, and they're saying 80 dB per meter. Not real familiar with using that type of signal, but what we're going to do is we're just going to use microvolts into a loop antenna, because basically what we're going to have to do is we're going to have to radiate the signal into the bar antenna, which is back here. You can see the bar antenna. We're just going to put this loop in proximity of the bar antenna. And I'll move all that out of the way here in a minute when I get the camera out of the way. And then we'll just set for just a medium strong signal, and we'll go from there. Okay, I have the power cord moved out of the way a little bit. I have the loop antenna kind of just sitting over the bar antenna. We're at 600 kilohertz, and we're on AM modulation now instead of FM, and I just have 90 dB microvolt in there. Again, we'll see what that looks like. We'll probably have to cut that down. That's way more than we need, but let's go down to 600 kilohertz, switch to AM, go down to 600, and we should be able to tune that station in right around there. And boy, we're right on it. Look at that. We're right on it. Pretty good there. That's a pretty strong signal. All right. Okay. Okay, I've cut it down to about 70 dB microvolt, like that, dBu. And I have a decent signal, but there's a little bit of static, and we want that. And then that way, when we kind of tune around it, you can see that we can go on and off of the signal. And right about there looks the best. And I can probably go down even a little bit more on my amplitude of the signal. And I'm just looking to get it as perfect as possible. See how it kind of right there, we're peaked out. So that's the center of the station. And we're off just by a tiny bit if you look at the pointer down here. All right. So what we want to do is we want to move this down to 600 right on the mark. And then we want to use that T401 to bring the signal back to looking like this. So first thing we'll do is we'll move this to 600 right on the button there. Then we're going to come over here. And you can see it's off a little bit. And we're going to go to T401. And T401 is right here. So this whole thing's kind of upside down how we're looking at it. So T401 is this red can right down here. Whoop, camera's in the way. This one. So I'm going to adjust that and just bring the signal right in. So here we go. Wrong way. And I'm going kind of through it. There we go. Whoop. Too far. Very touchy. Right there it is. Okay. So that took that, and it was just a tiny little adjustment is all that was. Now we're going to turn the cord. Actually, they want the core. That's a typo. And we're going to drop it to an even weaker signal, which we're already on 60 dB. And we're going to adjust the center of the bar antenna until we get a maximum peak out of that. All right. So that is going to be in the end here. And I'm going to have to use a little bit bigger adjustment alignment tool for that, which, let's see what I have. Okay, I'll probably use something like this, and it's plastic and non-conductive and non-metallic and all that. And we'll see if we can get any more out of this thing. So let's take a look. Okay. Got it to loosen up a little bit, but I don't really think this is going to make a big difference. Okay, that's going down. Did you see it go down a little bit? And right there is about as far as I can get it. And it's really not making a huge difference. So we're going to call that good. Okay, now we're going to go to 1350 kilohertz and similar signal, and we're going to adjust CT0 until we get maximum peak. So 1350, let's go up here. Frequency 1.35 megahertz. And I'll go up one click on the signal strength. And then we'll go down here. And 1350 should be right about in the middle here someplace. And I can see the signal strength maxes out right there. And we're just below 1400, so we're a wee little bit high. This is 1300. 1350 would be exactly halfway between the 1400 and the 1300. So we're a wee little bit off, but you can see how nice it tunes. So all we want to do is bring the pointer exactly in the middle, about like that. And then we're going to use that CT0, which I'm holding this upside down on purpose. CT0 is right here, so that would be the 1, 2, 3, fourth one over from the right. So I'm going to go here, and I'm going to go 1, 2, 3. That'll be this one right here, and we're going to bring it until it's right on. So let's see where we get with this. And there we go. Whoop. Very, very touchy once again. Right there. Okay. And that brings it right on. Okay, we're at the same frequency, and now they want us to adjust CTA. And again, we're also looking at the signal strength meter down here while we're looking at the peak on the scope. Okay, and we want to adjust CTA, which happens to be, as I hit the camera stand, the second one over. So let's, and I'll go over to the meter this time, and I'll show you what it looks like as we adjust this. And I probably should move the camera down here. Let me move the camera down. All right, and let's adjust CTA now. And I don't know if it's even showing up on the meter. It really isn't. It's showing up for sure on the scope, but not so much on the meter. And we're looking at this meter. This is for FM. Watch when I go on the scope and make the adjustments what it does. And this is why you need to use your scope as well. You can't just rely on the meter itself. All right. So when we make this adjustment, see how it just dropped? See how it just came back up? And there, drops again. So right there's your peak. Okay. The meter isn't moving hardly at all, but you can really see it on the waveform. Now for these next things, you're just going to go back and forth between 600 and 1350, back and forth until you get the dial accuracy to track plus or minus 1.5 millimeters off of the mark on the dial face. And then you're going to go to 950 kilohertz and just make sure that it's on, and it needs to be within 2 millimeters. So we'll go back and forth and I'll come back. Okay, I really didn't have to touch anything, and when I'm right on top of the 950 kilohertz station, you can see we're well within that 2 millimeters of the 950 kilohertz dial scale. So the dial scale accuracy is set. Okay, now we're back in the FM section again, and we're going to adjust the discriminator balance. And to do that, they want you to go to a detuning point, meaning a place where there's no station or anything. And you want it to be near the middle of the scale, which is 98 megahertz. So if there's any stations around you, you may have to tune a little bit on one side or the other of that. And looking up here, if you hit a point of zero signal, first of all, your signal meter should be right about at zero, and the stations, you should just see static, and it should be equal static on both channels. And we're pretty close to that right now. So there's really nothing around there. We just have a minimum signal with kind of nothing on there, and that's what we want. Okay, being down in a basement at the bottom of a hill makes it a lot easier for that. Okay, then what you want to do is you want to use the top core of, what are they calling it, T101, which is going to, usually the discriminator coil in these tuners, I don't even care what manufacturer, it's always the big tall square metal one quite often. And of course, as soon as I say that, some of you will come out with some tuner that doesn't have it that way. And there it is, sure enough, T101. Okay. And for that, we're going to need one of these tools here. How about this little tiny green one I have here? Maybe it will fit. Yep, that's the one. Okay. And what we're going to do is we're going to adjust that top slug, because there's a top and a bottom in these. There's actually two slugs in these coils, an upper and a lower. So we're going to adjust the upper one, and we want the meter to be centered. So we want it to be on 0. So if you look here, you want this to be centered. And you can see it pretty much is right now. I mean, it's very, very close. But I'll move this just so you can see what it does. So if I adjust that, see how it moves off? I'll put it right back where it was. And it's right on there. So the discriminator was perfect on this. Okay, now the next thing we want to do is we want to go to 60 dBu of amplitude, tune the radio and the signal generator to 98 megahertz, and you're going to tune it right on the station. And when you get perfect tuning, you want the meter to be on 0. And all we're doing is we're just adjusting to make sure that this adjustment is correct, and it is. So we're on 98 megahertz, and you can see the tuning meter is dead on. All right, there's your 98. There we go. Now this will be the last adjustment that we can make in this radio, or in this receiver, with the 8657 without having some sort of an external modulation for it. And we can continue to use it, but you need to have a stereo modulator, a multiplex modulator, to plug into it. If not, you'll have to use a different piece of test equipment, which is what we're going to do, even though I could do that. So the first thing we want to do is we want to set the VCO free run frequency. We're going to use VR201, which is going to be 201 is right here. And this is where you're going to set your 19 kilohertz. And they want us to measure with a frequency counter. They want this to be perfect. Okay, so what we have to do is we have to put a frequency counter onto this 19 kilohertz test point, which is right here, right by these adjustments. And right here we're going to adjust this VCO frequency for 19 kilohertz. So you can see I already have the lead connected there, and let me move the camera up. You can see that we are definitely not on 19 kilohertz. It's actually 358 hertz off, and you're only allowed plus or minus 20 hertz, so we have to adjust that potentiometer. So I'm going to adjust it, and let's see what we get. And of course I go the wrong way. We're just going to drop this down to we're right at 19 kilohertz. That's pretty close, and I went too far. There we go. This potentiometer is dirty. There we go. That's pretty close, and see it kind of bounces around a little bit, but that's right where we want it. So that good enough. Okay, as you can see, we've switched over to the SG80, and I could have just come out of this with multiplex and, modulated the 8657, but we're just going to use this right now. We're set to stereo. They want 100% modulation. We're pretty close to it. And 98 megahertz. And we just have a normal stereo signal, and all they want us to do is set the other part of the discriminator can for minimum distortion. So you can see on the scope I have one channel connected up just to monitor it. We're tuned on channel, and then we have the distortion meter connected. And what we're going to do is we're going to adjust the bottom slug of the discriminator coil now. All right, and we're going to set it for minimum distortion. It's probably already there, but let's see. Definitely not that direction. Yeah, we were there already. So get back in here. This is kind of tough because this slug is a little bit difficult to turn. We're definitely going the wrong way there. You can see that's about it right there. Okay, the next thing they're going to have us do is we're going to switch to left only. They want us to just go to left channel in stereo mode. And then they want us to adjust the core of IFT. I'll just go down here and I'll show you what we're talking about. They want us to adjust the core of this can right here, and this potentiometer right here for minimum distortion. Okay, so let's get on the, I'll get you onto the distortion meter and we'll do that. Okay, the first thing we're adjusting is the IFT can. Wrong way. This one's probably also pretty close. And you can see where you have to kind of wait for it to settle. And that's right about where we were. That's about it. That's all I can get out of that one. Now we'll do the potentiometer. And I need a different adjustment tool for that. And I have a feeling it's going to be the same thing. It's just going to... wrong way. Getting that. Ooh, that one's coming down. Ooh, that was out a good bit. Wrong way. Wow. I think right there is about where we're going to get it. Wow, that cut it in half. That's very good. Perfect. All right, that cleaned it up quite a bit. Okay, the next thing we're going to adjust is stereo separation. And that's going to be potentiometer VR202. And when we look at that, that is 202 is separation, which is this one right here. All right. And we're going to adjust that with left and right. So there's, let's connect the scope. All right. And we're going to go through, going to go back to stereo. And again, we're going to adjust this potentiometer right here. If you could see it right there. Right down in there. And we're going to adjust for separation. And it looked pretty good when I looked at it earlier. Just a quick look at it. But let's see what we get. Okay, so we're going to go flat as a pancake for right, flat as a pancake for left. So I'm not going to touch it. So you can see they're both very, very flat. So we're going to leave that alone. That adjustment is good. Okay, the next thing we're going to adjust is the pilot signal erase, and that's just getting rid of the 19 kilohertz pilot tone from the audio. And it's already perfect, but we'll go through it anyway. So essentially what would happen is we're setting the signal generator to have multiplex stereo with no audio modulation. So you're basically transmitting a stereo carrier with no audio on it. And you're putting that into the antenna terminal. And then what you're going to do is, the only thing that we're modulating right now is the 19 kilohertz pilot. And if we have the pilot trap set properly, you should not see a 19 kilohertz waveform on the audio. And it's pretty minimal. Let's see here. I mean, there's just nothing there. So we'll look at it. I had to set my scope here. And you can see I have the sensitivity all the way up to 10 millivolts per division. Very tiny signal. And there is no 19 kilohertz waveform on there anywhere. Now, if there was, you'd see what looks like a sine wave at 19 kilohertz, and you would just adjust that that little transformer and that potentiometer until it's zeroed out. But as you can see, it's perfect. If we put audio on there, you could see how quickly that signal goes in there. It's a great big audio signal. So the 19 kilohertz trap is set. Okay, the next thing we want to do is we want to set the signal meter sensitivity. So that's this meter right here. And what they're asking for is they're asking for an 80 dBu pilot tone. So they just, or I'm sorry, carrier signal. So they just want 98 megahertz with no audio or no modulation. And they want a signal amplitude of about 80 dBUV. Okay, that's the way they're doing it in this instructions. Different people have different ways of expressing the amplitude, but they just want micro dB with reference to microvolts. So 80 dBu. And with 80 dBu in there, they're saying that you should have, and you can see I have it set to that up there. I don't know if the meter will, or if, there it is. And if you look, we're darn near there. Now what they're saying is with 80 dBu, they want the signal meter to go to 90. Okay, because this is not dBu, this is actual just signal quality. So we're very close, we're almost there. So they're going to have us adjust VR 301, which is the, let's see where it's at. It's right in front of the, let's see, right in front of the tuning gang. There's this other pot that we haven't adjusted yet. And they just want us to adjust it until it goes right on to 90. Now, I have you a little bit of an angle. We'll try to get as straight on as we can. And you can see it's really close already. But we'll get it perfect. And let's adjust until we get right on to 90. And that's about it right there, huh? Barely even a touch on it. So this tuner, other than that one distortion adjustment for the left channel, everything else was almost dead on. We had very little, we had a little bit of the dial accuracy alignment to do, which was very tiny. But other than that, it's good. I think it's ready to test it out and see if it can tune anything. Okay, as you can see from the absolutely crappy muting circuit, it keeps dropping in and out. And if I touch the knob, you can see it'll disable this. If I let go, it'll come in. And you can see it's a stereo station, but the muting threshold is just so high that it just won't stay in. And this is the strongest station I can get down here today during the day. If I come back in the evening, it gets a little bit better, and it'll stay locked in on this channel. But very frustrating, but that's how this receiver works, and that's one of the things I don't like about this receiver. If I were going to have a receiver upstairs that I was going to listen to as a daily driver, it would not be this one, simply because of that muting circuit. And you can't really adjust it. So I'm not going to go through and do much tuning through stations at the end of this, because you're not going to really hear anything. If I go into mono, so I disable this, it'll stay on, but it never goes into stereo mode. So unfortunately, that's the way it is. But anyway, you can see relatively strong signal, but it has to be even stronger than that for it to lock. You need at least about a 30 on the scale there for it to really lock in. So anyway, that's complete. Everything's working well. This is working as it should be working. And another receiver this one's probably going to end up going to a good home somewhere. And that's it. So until next time, I wish you all peace, joy, happiness, and good health in your lives. And thanks for coming along on this one. And if you have any other questions, feel free to ask them down in the comments, and I'll do my best to answer them to the best of my ability, as I have time to. Things have been really busy lately, so I can't always answer questions or comments, but I try to, especially if there's something important, somebody's in the middle of working on something. And of course, my patrons can always reach me through Patreon. All right, take care, everybody, and stay well. Bye-bye.